expressions. This is in the textbook, 17.1. Your essential question: what are polynomial expressions and how do you simplify them? Your learning goal: I can rewrite a given polynomial in standard form. So to do this learning goal, we need to learn what a polynomial is, and we need to learn what standard form is, and then we need to learn how to rewrite a polynomial in standard form. We're going to do that today. So we have a couple of slides that are just a little bit of review, and I think this is why this lesson took a little bit longer. So these are some basic skills that you should be fluent in, and if you're not, I'm just going to kind of review how to do it real quick and remind you that you are allowed to use a calculator to add and subtract integers. Okay, this is not the standards that are for Algebra 1. These are things you need to know how to do. If you feel comfortable with it, great. If you don't, use a calculator. But anyhow, when you add and subtract integers, so like -9 plus -6, right? The way you should think about it is you're going to find the sum of 9 and 6, which is 15. And then because they're both negative, we're going to use that same sign. So it's -15. Next example here, 14 plus -17. So the way you should think about this is that these are different signs. So you want to find the difference. And the difference between 14 and 17 is just 3. And then to determine which sign 3 should it be +3 or -3? You look to see which has the greater absolute value. 17 is a greater absolute value, so we're going to keep 3 as a negative. Other example here, 3 minus -11. So whenever you subtract a negative, you're actually adding the opposite. Right here, let me add to this line tool. Write this down. So when you add the opposite, you know, you could think of that as adding the opposite, or there's also a saying called drop a line and change the sign. Maybe you've heard that before. Okay, so there we go. That's what we're doing here when you have the minus and the negative next to each other. So it turns into 3 plus +11, which is just regular addition, so it's 14. So I want you to try 1. Everyone try 1. Then when you finish 1, try 2. If you finish 2, try 3. I'm going to give you a minute to do whatever you can on this slide. Just 1 minute, because, yeah, minute 11 seconds. There you go. So participation here. 4 of you are participating. Woohoo! I'm up to 5. Okay. Period 3, I think the most I ever got was 7 students on one slide. So I need you to beat them for sure. Period 4, I got up to like 16. So we're up to 6. Again, there's still some of you that should be in the Pear Deck who are not there yet. Didn't even start the timer. So we're probably more along 45 seconds left. Yeah, I don't know, Isaac. I don't know. It's a great question. The same kind of mini speech I've been giving all my classes today is that you're not going to learn math passively. You have to be an active learner. You have to try, you have to fail, you have to try again until you get it. That's how math is. You just keep doing it until you get it. You can't just stare at it and expect to understand it. It won't work. Okay, the people that are consistently participating in the Pear Decks, joining the classes all the time, these are the students that are passing. If you're not passing, ask yourself, are you doing the Pear Decks? Are you participating? Are you doing the assignments? Okay, you have to be an active learner. Why are all these things there? All right. Anyhow, let's see what we came up with. 7 of you participated. You guys are like 3rd period right now. Come on, we can do better than that. -16 plus 21. This person says it is 5. Is that correct? Opposite signs, different signs. So you subtract and keep a sign of the bigger one. Yes, it is 5. Negative 13 minus 12. This person says it's negative 25. Well, these are both negative numbers. So basically, it's like this first example, adding two negatives. And we keep it negative, and we add 13 and 12 and get negative 25. That is correct. The last one, not right yet. It's not negative 31. So 1 and 2 are correct here, but not 3. That's mine. Same answers. Let's see. Subtract 5, sub 5, add negative 5, 25. Okay. This we will end up adding, because see how we have a minus and a negative? You're going to drop a line and change the sign. Okay, here we go. Negative 15. This person figured it out. It is negative 15. So when you drop a line and change the sign, or you add the opposite, this turns into negative 23 plus positive 8. All right, so these are the correct answers there. Good. Okay, another review slide. There's 2 of them today. Algebraic expressions. Simplifying algebraic expressions involve combining like terms. So here's an algebraic expression. 15 plus 9x minus 6 minus 5x. Has 4 terms in it. 15, 9x, negative 6, negative 5x. Again, when you think about terms, your terms are the pieces that are added together. So this is like, instead of negative minus 6, I could think of this as it's adding negative 6. Instead of subtracting 5x, I could rewrite this as adding negative 5x. Then when I want to rearrange things so that we're grouping them together, the like terms together, we know where to move that subtraction symbol where it goes. So it belongs with the 6, it belongs with the 5x. So 9x minus 5x plus 15 minus 6. Combine the terms. 15 minus 6 is 9. 9x minus 5x, you just subtract the coefficients. 9x, take away 5x. If you have 9 x's and you take 5 x's away, there's 4 x's left. So the last thing here is 4x plus 9. And we can't combine this anymore, okay? Like terms have the same variable part. They are either like both just numbers, like 15 and negative 6, or they both have an x, or they both have a y, or they both have a c or a d, whatever. And so we're going to simplify by combining like terms here. You're going to do number 4 and number 5. So I'm just going to have you do 2 of these. Some of you, I've noticed I changed the slide mid working through it today, so I don't know if more problems show up for you. You only have to do them 4 and 5. Right, and I'm going to give you a minute and a half to do 4 and 5, or start 4 and 5. Why is there so much ads? It wants me to subscribe to a timer channel. That's just silly. Okay, so about another minute, try this. Okay, right now, how many of you are trying it so far? Let's see, 6 of you have started this. All right, everybody else, start it, try it. You should not be just sitting in the meet right now. You should be on your Pear Deck tab. You should be actively working on your Pear Deck tab. Thank you. I've actually seen like 4 or 5 screens switch over right now, so that's awesome. Okay, So time is up on this. We're going to take a look at what you wrote. I got 11 of you to participate now. So a little bit more than last time, last slide. We're getting better and better. So we want to simplify. Let's see. Oh, 12. Did I say that? Was it 11? Did it go to 12? I don't know. This one's mine, so that one doesn't count. Let's see. Number 5 is correct here. Okay. Number 4 is not correct yet. -7 minus 6 is -13. And D plus 2D is 3D. So this is correct. You could even have this term before this term. You could have 3D minus 13 or 3D plus -13. That would also work, but that is correct for 5. And then this is correct for 4. This is good. These are both correct now. 8A minus 10A. 8 minus 10 is -2A. 5 minus 11, -6. Okay, so we only combine terms that have the same variable part. We can combine constants. And this is how you do it. So if you are getting stuck on, those integer rules. So just to go back real quick, these adding and subtracting integers. If you're getting confused on this stuff, use a calculator to do your work. That's totally okay in Algebra 1, right? You're not in 7th grade. This is not the standard that you're being tested on. So use a calculator. You don't want to miss a problem because you made an error adding a positive and a negative number together. Okay, so that's some review about integers, adding and subtracting, and simplifying. And that just leads us into what we're going to be working with in this unit, okay? And so some new vocabulary. Actually, this is not new. Terms, you've seen this before. I just talked about it earlier. So terms of an expression are parts of the expression separated by plus signs. Remember that x minus y can be written as x plus -y. So another way to think of terms are, what are the pieces that are added together in an expression? Those are the terms. Now, here's a new word, monomials. Monomials. It's an expression consisting of a number, variable, or product of numbers and variables that have whole number exponents. Whole numbers, guys, are things like 0, 1, 2, 3, 4, 5. You can't have negative exponents. You can't have fractional exponents. They have to be whole numbers for it to work as a monomial. Okay? A monomial cannot have more than one term. Terms are the pieces of an expression that are added together. So if you see a plus sign in there in one term, that's not a monomial. It's just one term. Also, we cannot have a variable in the denominator. That's not allowed. This kind of goes with having whole number exponents. Okay, if you remember the rules for negative exponents and how they change depending on where you move that factor that has the negative exponent, it changes the sign by moving it from either the numerator to the denominator or the denominator to the numerator. That would change the sign on your exponent on a power. So no variables in the denominator, and when they're in the numerator, they have to have a whole number exponent. 0, 1, 2, 3, 4, 5, 6, 7, those kind of numbers. Here are some examples of monomials. 4x, sorry, you're going too fast. 4, just 4. It's just a number. That works. X, just a variable. That works. -4xy. Here it says it's okay. We have a product of numbers and variables. That's good. 2500ths x cubed. This is a product of number and variables, and we have a whole number exponent. 3 is a whole number. We're good. xy divided by 4. There's something in the denominator. But as long as it's not a variable, we're fine. It's just a number. So these are all monomials. They all consist of one term. Okay, the word monomial has in it mono, all right? So check this out. I found this earlier in 4th period. The word monomial. Mono means one or singular. And so this is just a picture of a tree where this is the root. Mono on the roots means one or singular. Here's a bunch of words that start with mono, like monopoly, or monopolize, or monologue, monochrome, monogamy, monotone, monotheism, monorail. Okay, so these are all things, if you think about them, it's singular, just one. And that goes with what we have here, one term, monomial. Not monomials, these are non-examples. 4 plus x, that's 2 terms, not a monomial. X minus 1, that's 2 terms, not a monomial. 0 and 7/10 times x to the negative 2 power. Well, this is a product of numbers and variables, but the problem is the exponent is not a whole number. This is a negative integer. That's not allowed. Like, same problem here, product of a number and a variable, but the exponent is a negative integer, not allowed. You can only have whole number exponents. The last one here, y divided by x cubed. Well, x cubed, that's a whole number, 3, but the problem is that we can't have a variable in the denominator, because what happens is I move this variable out of the denominator and I rewrite this expression as y times x to the negative 3 power, because that's the rule for moving it out of the denominator. Now we have a negative exponent. Okay, so monomials. Guess what? There's more monomials, not monomials, but without that. Let me just show you. What I'm trying to say. Polynomial. Okay, again, I'm going to show you this. If I look at the root word poly, poly means many. Here's my tree, many. So words that have poly in it: polyhedron, polyester, polygamy, polygon, polynomial, there's our word, polytheism. So there's different words that start with poly, and all these things in common means that we're talking about many, many. So a polynomial can be a monomial, or the sum of monomials. So you can add a bunch of monomials together. It's just like this umbrella term to talk about all the different types of polynomials are called polynomials. You have monomial, then we have binomial. Bi means 2. Bicycle has 2 wheels. Binomial has 2 terms. Trinomial. Tri means 3. Tricycle. Okay, a trinomial has 3 terms. A tricycle has 3 wheels. So there's special names when there's 1 term, 2 terms, or 3 terms. Monomial, binomial, trinomial. And they are all polynomials. All the many terms are polynomials. The degree of a polynomial, this is just a number. So the degree of a polynomial is the greatest value among the sums of the exponents on the variables in each term. That's a mouthful. Let's look at what that is. So, example here, we're going to classify each polynomial by its degree and the number of terms. Here's the first one: 7x squared minus 5x cubed y cubed. So this is a polynomial. More specifically, it is a binomial. The reason why it's a binomial is that there are 2 terms. Okay, 7x squared is a term. Negative 5 times x cubed y cubed is another term. So we just classified it by the number of terms. Okay, the number of terms, there was 2, so we call it a binomial. The other thing it's asking us to do is to figure out what is its degree. Okay, it says its degree is 6. Why is that? Let's find out. So we have to look at each term of the polynomial. I look at 7x squared. The degree is 2. If I look at negative 5x cubed y cubed, the degree is 6. Why is it 2? Why is it 6? So what you have to think about when you're trying to find the degree is you look for exponents on variables. So 2 find the degree. So there's the degree of a term and the degree of a polynomial. To find the degree of a term, look for the exponents on variables only. So 7x squared, x is a variable, its exponent is 2, so the degree is 2. Negative 5x cubed y cubed, x is a variable, y is a variable. 3 and 3. What you have to do is when there's more than one, you have to add them together. 3 plus 3 is 6. So that's what happened here. We had to add them together because there was more than one. If it's just a number, this is pretty interesting. If it is just a number, numbers have degree of 0. Because if it's just a number, there is no variable. So it's just 0. Let's look at B. Here's our polynomial, 3 squared plus 2n cubed plus 8n. To me, I think it's easier to figure out what type of polynomial it is by the number of terms. That's easier to see right away. I can see that there are 3 things added together. So that means there are 3 terms. And when there's 3 terms, 3 and tri mean the same thing. So this is a trinomial. All right, there are 3 terms, trinomial. What we have to do now is look at each term. We have to look at 3 squared. We have to look at 2n cubed and look at 8n and figure out what is the degree of each term. Okay, so to find the degree of a term, look for the exponents on variables only. 3 squared. Do you see a variable? There's no variable. It's just a number. 3 squared, there's no x, there's no y. So when there is just a number, we say the degree is 0. So this one is going to be 0. For the next one, 2n cubed, look for a variable. N is a variable. Look at its exponent. 3 is its exponent. That's the only exponent. So if I add up all the exponents, it's just 3. I don't have anything else to add it to. And then the last one here, 8n. Look for a variable. There's a variable, there's an n. What's the exponent on the variable? If you don't see it, there is one. It's just invisible. It's that little invisible one, right? So the degree of that term is 1. So this is how you find the degree of a term. You have to look at each term individually. The degree of the polynomial now, though, okay, now if I look at the definition, maybe it'll make a little more sense. The degree of a polynomial is the greatest value among the sums of the exponents on the variables in each term. So we found all the sums of exponents. We have to find the greatest one. The greatest one. We found 0 for the first term. We found 3 for the second term. We found 1 for the last one. What is the greatest number of 0, 3, and 1? What number should I put here in this degree box? What's the degree of that polynomial? It's the greatest number I found of 0, 3, and 1. I have 6 of you working on this. That's very sad to me. I have 18 students in the meet. It's like half the class in the meet. A third of the class is doing the work. A third of a half. 1/6. So if 1/6 of you pass, that's why. You don't do the work, you're not going to pass. I'm telling you, it's extra difficult. I'm up to 9 of you now. The degree of our polynomial, the greatest term, the greatest degree of a term of 0, 3, and 1. What's the biggest number of 0, 3, and 1? This person has it. It's 3. The degree is 3. So that's what goes in this box. 3. So I'm going to leave that there for a second to get caught up. We have 10 minutes left in class. I have 10 of you writing on your slide now. I'm going to go to the next slide. I'm going to leave it on student pace though, so I can do that. So this next slide here is more vocabulary. This is the last vocab slide. Okay, so 2 new terms. Standard form of a polynomial. This is our learning goal. Standard form of a polynomial contains only one variable and is written with the terms in order of decreasing degree. The first term will have the greatest degree. The next term will have the next greatest degree, and so on, until the final term, which will have the lowest degree. An example of that is down here. 5x to the 4th power. This term's degree is 4. Plus 4x squared. This term's degree is 2. Plus x. This term's degree is 1. Minus 2. This term's degree is 0. So it's in decreasing order. And also, there's only one variable. There's only an x. Okay? So no combinations of x and y and z and stuff. Just one. Standard form of a polynomial, just one variable. And your terms, you can rearrange the terms, okay, because they're all added together. You can move stuff around when you're adding. That's the commutativity property of addition. So you move them around so that the biggest degree is the first term. And then when you look at the first term, the leading coefficient, the very first number you see in front of that variable term, that's the leading coefficient. So when a polynomial is written in standard form, this is the coefficient of the first term, leading coefficient. The leading coefficient here is 5 because it is in front of the highest degree term. All right, we're going to move to slide 9. I am going to make you go to slide 9 right now. I'm not giving you a choice. All right. Write each polynomial in standard form. Then give the leading coefficient. So for A, we have 20x minus 4x cubed plus 1 minus 2x squared. All right. So find the degree of each term. So that's what they did here. So they have it written out, and then underneath, they're saying what the degree of the term is. So 20x has a degree of 1 because x has an exponent of 1. Negative 4x cubed. The degree is 3 because the exponent on the x is 3. 1 is a number. Anytime it's just a number, the degree is 0. Negative 2x squared. 2 is the exponent on the x term, so 2 is the degree. And then we're going to rearrange them. And so when they do rearrange them, you know, anytime you see the minus sign, it might be helpful to change it to adding the opposite on these. That way when you move them, you know where the sign belongs to. And so negative 4x cubed is first because that's the highest degree. And then negative 2x squared is next because that's the second highest degree. Then plus 20x, then plus 1. And so the degree order is decreasing. If you look for the very first thing you see in your polynomial in standard form, it's the coefficient in front. It's leading it. It's leading the group. That's why it's a leading coefficient. It's leading the whole thing. And in this case, it's negative 4. It's the number part of the term that's first. So if we look at B, z cubed minus z to the 6th plus 4z. Find the degree of each term and then arrange them in descending order of their degree. All right, so we just have this expression here. They haven't changed anything. They put in these little brackets for us so that way we can determine what each degree is of each term. So if I look at z cubed, well, the degree of that term is 3 because 3 is the exponent. 3. And then if I look at the next term, negative z to the 6th power, look at the variable z, look at its exponent, it's 6. Plus 4z, last term, 4z. Z is the variable, its exponent, I don't see it, so it's 1. 3, 6, and 1. And now what we want to do is rearrange the pieces so that it is in decreasing order. So 3, 6, and 1, 6 is the biggest. So the term that has the degree of 6 is first. And then the term that has a degree of 3 is next. And the term that has a degree of 1 is last. Okay, now it's just a matter of typing those in. The term that had a degree of 6 was minus z to the 6th power. Minus z to the 6th power. And Pear Deck is not the best for trying to type exponents, so I need to switch to the pen tool for that. And then after that, we have the term that has 3 as its degree, z cubed. It's positive, so it's plus z cubed. And then the last term is the one that has 1 as its degree, plus 4z. Okay. Right here, they're asking you to rewrite this here. So in some of my other classes, I saw some students do this, and you can totally do this. They just were like, yeah, this thing is going to go here, because I'm not going to try to write it again with Pear Deck, because it's not like just using a pen and piece of paper. It's difficult. The leading coefficient. Look at the term with the power that is highest degree, negative z to the 6th power. Very first thing you see is that negative, but it's not just negative, it's negative 1. You know, negative 1. Because that's what's right here. And I can even draw that in, okay? You know, you don't see it there, but there is an invisible one right there between the negative and the z. I could probably make it so there's even room for that. There we go. Look at that. -1. We made